In the previous lecture, we started about the components of solids, the components of colloids, right? So the most common colloid is what we have studied is the albumin. Is a principal natural colloid comprising 50 to 60% of all plasma proteins, right? It contributes to 80% of the normal octet pressure in health. So what are the physical properties of colloidal solutions? The physical properties of colloidal solutions are nothing but stability. This all we studied in our previous videos. So stability, colloids are relatively stable in nature. Colloids are relatively stable in nature. The particles are stable in nature. So the particles of the dispersed phase are in a state of continuous motion and remain suspended in the solution. Right? Remain suspended in the solution. And stability and filterability. So here in case of filterability, we use some specialized filters known as ultra filters for filtration. So these are the two physical properties of colloidal solutions. Physical properties of colloidal solutions. One is the stability and other is the filterability. Stability and filterability. So these are the two important physical properties of colloidal solution. So if you come to the characteristics, as we studied, so characteristics of colloidal solutions are colloid shows the Tyndall effect, right? Tyndall effect which comes from the Brownian motion, right? So colloidal shows the Tyndall effect, that is colloidal particles can scatter a beam of light, can scatter a beam of light passing through them and make the path of light visible. Colloids also exhibit Brownian motion, that is zigzag random motion of colloidal particles. Zigzag random motion means with this type of motions. So this is what the zigzag motion, that is one particle, another particle, somewhere here. So this type of motion is what we call it as the zigzag motion. Right? So that is what zigzag random movement of colloidal particles in the solution. So these are the different components of solids and properties of solids. If we come to physical properties, the physical properties are one is the stability and other is the filterability. And the two main important characteristics of colloidal solutions are colloidal shows the Tyndall effect. Right? So that is one of the important characteristics. Right? Colloids also exhibit Brownian movement, that is zigzag random movement of colloidal particles in the solution. Now, if you come to the properties of colloids, so in this today lecture, we'll study about the properties of colloids. Right? In order to be classified as a colloid, the substance in the dispersed phase, right, must be larger than the size of a molecule, but smaller than what can be seen through the naked eye. Right? So in order to be classified as a colloid, the substance in the dispersed phase must be larger than size of a molecule, but smaller than what can be seen through the naked eye. Right? So this can be more precisely quantified. That point can be more precisely quantified as one or more of the substance dimensions. Substance dimensions must be around 1 and 1000 nanometers. The quantified as one or more of the substance dimensions must be between 1 and 1000 nanometers. If the dimensions are smaller than this substance, the substance is considered as a solution. If they are larger than that substance, we call it as suspension. Right? So one is solution and other is suspension. Right? So that is what the dimensions. So the substance dimension should be around 1 and 1000 nanometers. 1 and 1000 nanometers. Right? If the dimensions are smaller than this, is considered as a solution. The dimensions are considered as solutions, and if they are larger than the dimensions, then we call it as there can be suspension. So a most common method, right? A most common method of classifying colloids is based on the phase of the dispersed, substance and what phase it is dispersed in. The most common method of classifying colloids is based on the phase of the dispersed substance and what phase it is dispersed in. Right? There are two initial methods of classifying colloids. One is the phase of the dispersed substance. One is the phase of dispersed substance and what phase it is dispersed and what phase it is dispersed. So these are the two important methods of classifying colloids. So that is what a common method of classifying colloid is based on the phase of the dispersed substance and what phase it is dispersed in. Right. So these are the two common methods of classifying colloids. Right. So this type of colloids, the types of colloids include solute, as we have seen. The types of colloids include sol, emulsion, foam, and aerosols. And sol is a colloidal suspension with solid particles in liquid, and emulsion is between two liquids, and foam is formed when many gas particles are trapped in a liquid or solid. And aerosol contains small particles of liquid or solid dispersed in a gas. So a common method, this is what we have seen, the common method of classifying colloids is based on the phase of the dispersed substance and what phase it is. Right. So the types of colloids, there are different types of colloids as we have seen. Those include, one is the sol, and other is emulsion, and other is foam, and other is the aerosols. Right. And sol is a colloidal suspension with solid particles in liquid. Emulsion is between two liquids. And foam is formed when many gas particles are trapped. Foam is formed when many gas particles are trapped in a liquid or solid. Aerosol contains small particles or liquid or solid dispersed in a gas. Right? So these are some of the properties of colloids. These are some of the properties of colloids. Right? If you go for further continuation, properties of colloids, say it is a homogeneous mixture. The size of colloidal particles is very small, as we have seen. If you come to the overall summary of the properties, if you come to the properties of colloids in the overall summary, we can tell it is a homogeneous mixture. The size of colloidal particles is very small. The particle size ranges between 1 to 1000 nanometers. It shows the Tyndall effect. We'll see this Tyndall effect. What is this Tyndall effect later? So Tyndall effect is a phenomena in which the particles in a colloid scatter the beam of light that are directed at them. That means if you take this is a light source, right? So this is light source, right? When this light source is immersed on a true solution, right? So this is a beam of light that is passed, right? And this is a beam of light that is passed, and this is what the path of light is, right? Path of light visible. This is the path of the light visible. This is the path of the light visible. This is what call it as path of light visible. Path of light visible, which is due to scattering. This is a light source. A light source is allowed to fall on a true solution, what we take colloidal solution. And if you see that, so we can observe the path of the light visible in that solution. So that is what this is obtained due to scattering. So that is what we call the Tyndall effect is a phenomenon in which particles in a colloid scatter the beam of light that are directed at them. This effect is exhibited by all colloidal solutions. This effect is exhibited by all colloidal solutions and some very fine suspension. Therefore, it can be used to verify if a given solution is a colloid or not. Right. So this is one of the this is one of the property, that is Tyndall effect, that is which is existing due to Brownian motion and all. Therefore, it can be used to verify if a given solution is a colloid. When a strong and converging beam of light is passed through a colloidal solution, its path becomes visible. That is what we are seeing this is what the path, this is what the path we have seen. The path, this is visible. So is passed through a colloid, its path become visible when viewed at right angles to the beam of light. So this effect is what we call it a Tyndall effect, and is due to scattering of light by the colloidal particles. Right. So they do not settle down when left undisturbed. They do not settle down when left undisturbed for some time. Right. They do not settle down. The particles do not settle down when left undisturbed for some time. They cannot be separated by filtration process or stability process. Right? They cannot be separated by filtration process or separation, and can be separated by centrifugation. And can be separated by centrifugation. This is essential characteristics which we can separate the colloidal solution. Right? So that's what this. So these are some of the properties of colloids. Right? So if you come to the general colloids, if you come to the general properties of a colloid, so we have the particles of the dispersed phase. The particles of the dispersed phase are relatively large. The particles of the displaced phase are relatively large. Right? However, they pass through ordinary filter media. So the dispersed phase does not dissolve in the dispersion motion, right? So dispersed phase does not dissolve in the dispersion medium. Right? The dispersed phase does not dissolve in the dispersion medium. So as we know that one of the essential property that the scatter light, where we can see the path of the visible light, that is what the Tyndall effect. That is what the scatter light. That is what we call it as Tyndall effect. And these particles show random motion, which is called Brownian motion, that is due to collision with molecules of the dispersed medium. So particles show random motion or Brownian motion due to collision with molecules of the dispersion medium. Particles absorb ions. Absorb ions. It is not absorbing, it absorbs ions, its own ions in preference to others. Particles may have electrical charge. This is a very important property. Particles may have an electrical charge which leads to repulsive forces, which stabilize the colloidal dispersion and prevents its coagulation. Right? So the particles may have electrical charge which leads to repulsive forces. Which stabilize the colloidal dispersion and prevents its coagulation. When the particles of the dispersion phase join together, they coagulate and separate due to gravity. Right? So particles have large surface area. Colloidal suspensions have negligible effect on colligative properties. So in general, these are the general characteristics, these are the general properties. That means they show the Tyndall effect, and the particles show random motion, that particles undergo Brownian motion due to collision with molecules, and particles absorb ions, right? And particles have electrical charge which leads to repulsive forces, which stabilizes the colloidal dispersion, and prevents its coagulation. Right? When the particles of the dispersion phase join together, they coagulate and separate due to gravity. Particles have large surface area, and colloidal suspensions have negligible effects on colligative properties. Right? So So these are some of the properties of colloids. If you go for some of the basic, some of the fundamental properties, there are some fundamental properties. One is a kinetic property. First, one is a kinetic property. What is a kinetic property? Write neatly. Kinetic property. Right. So this is one of the important property. That is what kinetic property. Second one is optical property, which comes due to Brownian motion. Optical property, Tyndall effect, and third one is electrical property. So these are the three different important properties of colloids, the general properties. That's why while dealing with properties of solids, we write in general. That's why we write in general. Colloids have the following properties, right? So the particles of the disperse phase are relatively large. However, they pass through ordinary filter media. So that's why we write that dispersed phase does not dissolve in the dispersion medium. The dispersed phase, the particles of the dispersed phase are relatively large, right? So the dispersed phase does not dissolve in dispersion medium. They scatter Tyndall effect. Particles show random motion, that is, the particles show Brownian motion due to collision with molecules of the dispersion medium. Particles absorb ions. Particles absorb ions, that is, some ions in preference to others, right? Preference to others. So particles will have some electrical charge, which leads to repulsive forces that stabilizes the colloidal dispersion and prevents its coagulation. Right? When the particles of the disperse phase, when the particles of the dispersion phase join together, when the particles of the dispersion phase join together, they coagulate and separate. They coagulate and separate due to the gravity that is present. Right? So particles have large surface area. We have particles a large surface area, and colloidal suspensions have negligible effect. Colloidal suspensions have negligible effect on colligative properties. Right? So these are the some properties of colloids. So if you come, as we know that, as in the previous lecture, we have seen there are certain different properties. One is the kinetic property, other optical property, and other is electrical property. Let us see what is a kinetic property. Let us see what is the kinetic properties of colloids. Right. So one of the kinetic property which gives, that is what the Tyndall effect, kinetic energy, right? Kinetic. So that is what is existing due to Brownian movement. So that's why we write kinetic property. The one of the essential properties when we speak about kinetic property of a colloid, then we need to speak about the Brownian motion, right? So the Brownian movement, it is also termed as Brownian motion and is named after the discovery by Robert Brown, a botanist, right? So he's a botanist. So he had discovered this particular motion, that is called Brownian motion. Brownian motion is a zigzag movement. Brownian motion is a zigzag movement, right? So that is what if you see here, if you see there are certain molecules and particles. We have one particle here, we have another particle, another particle somewhere here. So it is nothing but the motion is nothing but the zigzag motion, right? So this is what the path followed by the each one. So this is what the zigzag motion, right? So this is what the zigzag motion. That's what Brownian motion is, a zigzag movement of collider particles in continuous random manner. Brownian motion arises. Why? The reason for the Brownian motion is because of the impact of molecules, because of the impact of molecules of the dispersion medium on the particles of dispersed phase. So this Brownian motion basically arises due to the impact of the molecules of the dispersion medium on the particles of dispersed phase. So that's the reason why the Brownian motion arises. Brownian motion arises because of the impact of the molecules of the dispersion medium on the particles of the dispersed phase. Right? So the forces are unequal in different directions. The forces, whatever the force that is imparting, what is the force that is imparting on each molecule? So the forces are not same, right? The forces are not same, and the forces are unequal in different directions. Because it is a random motion, the forces will be different in different directions. So there is a reason why we write the forces are unequal in different directions. Hence, since the forces are different in different direction, hence we get the path followed by the molecules due to the dispersed phase, on the particles of dispersed phase is nothing but the zigzag way. That's why we get, hence it causes the particles to move in a zigzag way. So this is what the motion we can see here. If you see from this figure, so these are particles that move in different directions in a zigzag way, right? Hence, it causes the particles to move in zigzag way. That's why when we speak about the kinetic properties, so when people speak about kinetic properties, they need to talk about the Brownian motion, Brownian movement. So it was termed as named after the discovery of Robert Brown. He is a botanist, right? So it is a zigzag movement of colloidal particles in continuous random manner. So if there is a continuous random manner, the particles move in different. The particles have continuous random motion. So this particle collides with other. So in this criteria, the particles will have different path, right? So different path, right? So due to that different path, so it has some zigzag movement, right? Zigzag movement. So Brownian motion is a zigzag movement of colloidal particles in continuous random manner. So Brownian motion arises because of the impact of the molecule. Brownian motion arises because of the impact of the molecules of the dispersion medium on the particles of dispersed phase. So the forces are unequal in different directions, hence it causes the particles to move in a zigzag way, right? So if you continue, and these kinetic properties, if you see, not only that Brownian motion, these properties used to detect stability of a system. They also used to detect the stability of a system and molecular weight of the particles and transport kinetics and transport some kinetic energy. So that is what used to detect stability of a system, molecular weight of particles, transport kinetics. So as we know, as we have seen that it includes Brownian motion and it has some parameters like diffusion, sedimentation, viscosity and colligative properties, right? So if you speak about the Brownian motion, we know that it was named after the scientist called Robert Brown, who is a botanist. So Robert Brown theory states colloidal particles of 5 micrometer, continuous random motion because of thermal energy, right? Because of thermal energy, it is 5 micrometers. So colloidal particles of size 5 micrometer, continuous random motion because of thermal energy. In motion, they collide with walls. In motion, due to the random motion of the particles, they collide with the walls of the particle walls, other particles, and change the direction. They change the direction, right? Once it changes the direction, the velocity can be we can determine the velocity also, right? And change the direction, then the velocity and all. So that is what we can be seen through light microscope. So particles move against the gravitational force. Right? Particles move against the gravitational force. So Brownian motion stops with increase in size and viscosity. Brownian motion. So see that some of the characteristic properties of Brownian motion. That is, this theory states colloidal particles of 5 micrometer continuous random motion because of thermal energy. In motion, they collide with walls. Other particles, and change their velocity in different directions, right? So which can be seen through a light microscope, right? And particles move against gravitational force also. So particles also move against the gravitational force. Brownian motion stops with increase in size and viscosity. Also, right? So as you have seen that as you have seen in our previous as you have seen the general properties, the scattered light, that is what we call about Tyndall effect, right? So Tyndall effect, if you see the clear picture of Tyndall effect, light scattering is visible in dark background at perpendicular angle. So light scattering is visible in dark background at perpendicular angle. This is a narrow beam, so this is what a Tyndall beam. So this is a colloidal suspension, and this is what the path that is scattered. So this is a narrow beam or Tyndall beam. So this is a colloidal dispersion. These are the colloidal dispersion, and the path is scattered in different directions. So this is what we observe. When light is scattering is visible in dark background at perpendicular angle, right? So if you come to this light scattering, as we see that light scattering is clearly visible in dark background at perpendicular angle. So this light scattering studied in light ultra electron microscope. So where this light scattering can be studied? So light scattering can be studied in light, right? Ultra electron microscope. This is what the electron microscope we have here. we have the electron microscope here, right? So these are studied in electron microscope, light microscope, right? Light microscope. So what is the source of the light microscope? The source of radiation for light microscope is the visible light. So light source of radiation is a visible light, and the separation between two particles are visible if the distance is between them is 0.2 microns, right? So the two particles are visible if the distance, the two particles, there is a one particle and this is one particle. So two separate particles are visible if the distance between them is 0.2 microns. If the distance between the particles is 0.2 microns, we can observe two separate particles are visible if distance between them is 0.2 micron, right? So this is not suitable for colloidal particles. So this is not suitable for colloidal particles. So these are the light microscope parameters. Thus the source of radiation should be visible light, and two separate particles are visible. Two separate particles are visible if the distance between them is 0.2 micron, and not suitable for colloidal particles. So that is what we study in Tyndall effect, right? So that is what studied due to light microscope. Another is, as you have seen that light scattering is studied in different parameters. One is the light scattering, light microscope, ultra microscope, and other is electron microscope. In light microscope, the source of radiation, as you have seen, should be visible light, and the two particles are visible. So the two particles are visible if the distance between them is 0.2 microns, and this is not suitable for colloidal particles, right? So that is what we observe through light microscope. If you come to the next microscope, that is the ultra microscope. In ultra microscope, this is observed in a dark field microscope. This is observed in a light microscope, right? So where it is observed, light scattering is clearly visible in dark background at perpendicular angle. And in ultra microscope we have dark field microscope. Ultra microscope we have the dark field microscope. This ultra microscope is used to observe the Tyndall effect, right? So here the dispersed particles appear as bright spots in dark background. See here, if you see here, these are the bright spots. 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 These are the bright spots that are appear at the dark background. So this is your dark background. These are the appear at the dark background, right? So these are the dispersed particles. Appear as bright spots in dark background and is used to determine zeta potential. There is a parameter called zeta potential. So ultra microscope that is viewed in dark field ultra microscope is also a dark field microscope which is used to observe at zeta potential. That is what we have the light source here. This light source is allowed to fall through on a sample through hollow cylinder for light, right? Where we get the sample, where we can see some bright spots, right? So these bright spots are appeared because of the background is black, because of the background is dark, right? And that scattered and the light is scattered in different directions. So that is what we can see. Through the slit. That is what we can see through our ultra microscope. So this is also one of the essential method. Okay, so this is also one of the essential method in light scattering. So light scattering is studied in light microscope, ultra microscope. We have some light source, so the light source is able to fall through a hollow cylinder for light. We have a corridor condenser, and the sample we can see this is what the scattered light is. This is what we can see, the scattered light, and we appear the dispersed particles appear as a bright spot because of the black background, right? So this is what we can see through ultra microscope, right? So this is what regarding the ultra microscope, and previous one is the light microscope, and next one is the electron microscope. So this electron microscope is used to measure particle size, right? So electron microscope is used to measure particle size, shape and structure of the particle, right? So electron microscope is used to measure particle size, shape, structure. And the radiation source is higher energy electron of wavelength 0.1 angstroms or 0.1 into 10 power minus 6 meters, right? So that is what radiation source. A radiation source means the higher energy electron should be around, the wavelength of the higher energy electron should be around 0.1 angstroms. As wavelength decreases, resolution increases. As wavelength of the incoming radiation decreases, as wavelength of the incoming radiation decreases, resolution increases. So particle photographs can be taken. Particle photographs can be taken. So this is what we can see. As you see in the Tyndall effect, there is a light source. There is a light source here, right? And this light source is allowed to fall on a true solution with colloidal particles. So this is what the light source. So this light is allowed to fall. So this is light source. So this is a true solution, right? And we have the observation for light source for the scattering. So this is what we have, the path. So this is the path of light visible. So this is what the path of the light visible. This is what path of light visible. Path of light visible due to scattering. So this is what we see in the Tyndall effect, right? So this is also what due to the light scattering factors, right? So electron microscope, ultra microscope, and light microscope are the three methods, are the three types of microscope where we can study, where we can see the light scattering, and the path. And next other parameter is called the turbidity. This method is used to estimate concentration of dispersed particles and molecular weight of the solute, right? So this turbidity is used to measure. This method is used to estimate the concentration of dispersed particles and molecular weight of solute. So the equipments used here are spectrophotometer, and there is the nephelometer. So nephelometer and spectrometer are the two instruments that are used to study the turbidity. That means used to study the turbidity, that is used to estimate the concentration of dispersed particles and molecular weight of solute, right? So this is what we study, the spectrophotometer and nephelometer, right? So if you see here, what is the spectrophotometer? Spectrophotometer measures the intensity of the transmitted light. Spectrophotometer measures the intensity of transmitted light, whereas nephelometer is studied, scattering light intensity is measured at 90 degrees and is applicable for lyophilic colloids. This is applicable for lyophilic colloids. And turbidity here in spectrophotometer, if you see the spectrophotometer, we have a light source. And which is allowed to fall on a slit. That means light is incident, and this is the sample, and this is what the transmitted light. So the intensity is measured here, right? So the turbidity light intensity relation, the turbidity intensity relation is given by I by I naught, where I naught is the intensity of the incident light. And I is the intensity of transmitted light, where I is the intensity of transmitted light, intensity of incident light, and L is the I is the intensity of transmitted light, and I naught is the intensity of incident light, and L is the length of the sample. Approximately it is 1 centimeter, and the tau is the turbidity factor. So that's why we write I by I naught. That's why we write I by I naught is equals to e power. That is what we write, I by I naught is equals to e power minus tau L, where I is the intensity of the transmitted light and I naught is the intensity of the incident light, and minus tau is the turbidity factor, and L is the length of the sample, which is estimated to be 1 centimeter, right? So in lyophilic colloids, we have high turbidity and high scattering and low transmittance, and whereas in lyophilic colloids, we have low turbidity, low scattering, and high transmittance. So this is what we study in case of spectrophotometer, right? Leophobic, here it is leophobic, and here it is leophilic colloids. Leophobic and leophilic colloids. Right. Whereas in nephelometer, here the scattered light intensity is measured to be at around 90 degrees, and this nephelometer is applicable for lyophilic colloids. This is applicable for lyophilic colloids, and lyophilic colloid. If you see the diagram, so if you see the figure, so this is a light source, this is incident light, this slit, and this is a sample, and intensity is measured here. So here the intensity is measured here. Here in this case the intensity is measured here. Here the intensity is measured around the scattered light, that is what the due to the slit at the slit position. So here the intensity, it depends upon the intensity of incident light and intensity of the transmitted light, and it depends upon the turbidity, right? So here we can distinguish between lyophobic colloids which have high turbidity, high scattering, and low transmittance. Whereas in lyophilic colloids, here in case of lyophilic colloids means which can be observed through nephelometer, right? Which can be observed through nephelometer, right? So we have the low turbidity, low scattering, and high transmittance. So these are the two equipments in which the turbidity can be studied. So that is what to estimate the concentration of the dispersed particles and molecular weight of a solute, right? So this is what spectrophotometer and nephelometer. If you study the light scattering turbidity, so light scattering turbidity is used to study proteins, polymers, association colloids, and lyophilic salts. Right? It is used to measure the molecular weight of polymers. The principle involved is light source, dimensions of the particle, wavelength of the light source, and goes to dimensions of the particles and gives the turbidity, which is a measure for scattered light. So here we have spherical micelles plus light gives light scattered in all directions, and laminar micelles plus light gives adjust in direction of light. Here, if you see the turbidity, light scattering, when we study about the light scattering turbidity, we have the expression turbidity tau equals to 16 pi R90 by 3. Okay, and here R90 equals to IR square by I naught, where I naught is the intensity of incident light and I is the intensity of scattered light, and R90 is the Rayleigh ratio. It's a Rayleigh ratio. R90 is the Rayleigh ratio, and I naught is the intensity of the incident light, and I is the intensity of the scattered light, and tau is the turbidity, and small r is the distance between scattered particle and point of observation. So this is what light scattering turbidity is. So if you come to the molecular weight turbidity relationship, so here we have, in case of molecular weight turbidity relationship, we have the graph Hc by tau equals to 1 by capital M plus 2Bc. Here we see this is a graph that is plotted between Hc by T and concentration, where C is the concentration of the solution and M is the average molecular weight of a colloid, and B is the interaction constant of solvent to solute system, and H is the optical parameter which is depending upon the refractive index. So that means the changes with concentration and wavelength of the light used. This is what the expression, or this is what the graph which can be seen here. If you draw the variation by taking Hc by T on the x-axis and concentration on the y-axis, we get the intercept with a negative slope, right? So this is what the expression we use to determine the molecular weight or turbidity relation, right? So if you okay, so this is what we study about the molecular weight turbidity relation, graph variations, and light scattering turbidity. And light scattering turbidity has certain micelles and all, and we have the light scattering parameters can be studied by this turbidity method, and the method is used to estimate concentration of the dispersed particles and molecular weight of solute. The equipments used are spectrophotometer and nephelometer, right? So this is what we study about the kinetic properties. So this is what we study about the kinetic properties of colloids, right? So the next video will study about the optical properties and electrical properties.
Like, share and subscribe. Hit the bell icon for more updates.